welcome to Timas TV. Today we are looking at quotient rule. Quotient rule is one of the methods we use in differentiation. And in applying this method, you need to have an expression like this. For example, having u divided by b. So it means that two functions will be divided. Can be trig, can be exponential, can be linear. For example, we are going to use these three examples to demonstrate how we can use quotient rule. So at this point, we have y equals to exponential minus divided by this, and we are asked to look for the y dx and also the second derivative of that. So let's see how we can establish this. Y being equals to this divided by all this, and we are saying that, and let u be this, and the u dx is minus this, and also v being cos this, the v dx is giving you minus sine x. So at this point we can use this formula, this minus u divided by, multiply by this, divide the whole thing by v squared. So at this point we are all going to substitute appropriately. So let's see, v is cos x multiplied by du dx. Du dx is minus, so you can put the minus here and write the exponential. Minus u is this, dv dx is minus sign, so this can be and affect the sign. We have that. Divide the whole thing by cos squared that. So in this case, we can actually simplify it. We can simplify this appropriately. We can have exponential minus x into sine x minus cos this divided by cos squared this. So that is how to look for the differentiation of that expression. So the next one is the second derivative, and this is equal to d dx into the y dx, and the y dx has been given, so we are actually looking for the dy dx again of this. So we have this divided by cos this. So at this point we want to extend this and do this way. So dy squared and this is going to take this form, d into exponential this into this minus cos this divided by cos squared x. So what we are going to worry about is cos x, cos squared x. Cos squared x is what we are going to deal with. So at this point we can actually see how we can look at the identities and see the better way of writing it. So at this point we can say this will give us cos x minus sine x. So this is cos 2x will give us cos this minus this squared. So since we are looking for cos, we actually say that this is cos squared x into 1 minus cos squared x. So this will give us square x minus 1 plus cos square x. And finally, we have this to be 2 minus this. So looking at the how you can make it simple in the simpler form, we this will can come here, so we're having 2 cos squared x into cos 2x plus 1. So cos this becomes this plus 1 divided by 2. So we can actually insert this here. So d squared, the x squared becomes exponential of this minus cos this divided by um, this, or this is divided. So that is still quotient rule, which we are going to solve it. So at this point, handling this, we have that this becomes, we are going to multiply this first. So we have this cos 2x plus 1 multiply with the differentiation of the denominator. And of course, when you look at this, it's still product rule. So we can keep this, and work with this. So at this point, this will be minus, this will be cos x, and this is giving us plus sine x. So at that point, we also keep this, and also keep sine x minus cos, and differentiate this. So that will give us minus this. All of this, divide it with this into 2x plus 1, all of them divided by 2, all of them raised to the power of 2. So we can actually do this. So let's work further to see what we can do to actually reduce the complexity of the solution. So we can multiply this out. So this will give us this whole becomes, maintain this 2 into this plus 1, and see how you can multiply this in, and also that will give us a phenomenon x multiplied with cos x. The same thing goes here, sine x. So we have done for that. This is minus, so we have minus exponential x, and also plus exponential cos x. We can divide the whole thing by this denominator, all of this raised to the power of 2. So we also have this to multiply. So this is giving us this into this time this exponential minus this divided by 2 cos 2x cos x, and also the same thing this time this, we have plus exponential this and cos 2x sine x. So having done that, we are doing the same thing to to this. So that will also give us that will also give us this will also give us plus exponential 2 cos, that is this, and the same thing is plus exponential 2 sine x. So having done that, we write this out. We have minus this cos this. All of this divided by log this squared. So let's see how we can further simplify the expression. And if you look at it, you realize that this is actually, looking at this, there's nothing to simplify. So we can actually write like this into 2 and cos 2x cos x plus, let's see how we can put cos 2x out, this, and we have just plus sine x. So that is for this and this. And also this and this, we can do something about that, and also this and this. So this plus this will give us plus 3 over 2 exponential this cos this. This is minus exponential this. So all this is divided by this plus this. So we look at how it is, and in this scenario we need to be very careful with the signs. We need to be very careful with the signs so that we will not make mistake. So at this point we have this sign comes from here. That is why this is negative, and also influences this, and we have that positive sign. So when we multiply this through, we have this and we have that finally. So that is how we can use quotient rule to carry out even the second derivative of a given equation. So number two is that y equals to cos x divided by this plus 2 this. So at this point we are still insisting on the formula. The y dx is this, du dx minus this, dv dx divided by b squared. So we are saying let v be this, and dv du is 2 plus 2, and also u is cos x, du dx is minus sin x. So at this point, let's make room for that, and we can further work on this and see how we can do it. So dy dx is actually multiply the v into du dx. Du dx is minus that, so we can put the minus and add this. So minus u is cos x, multiplied by dv. dv is 2 plus this. So divide the whole thing by v squared. So we have this plus this divided by 2. So dy dx is actually equals to minus sine x minus 2x sine x, that is multiplying this. And the same vein, 2 cos this, and also multiply with minus 2 cos x. All this divided by this or this. So dy dx is um, actually equals to this minus 2x sine x, 2x cos x divided by this. This is 2 placed. So that is the answer for the second question. Finally, the third question is y equals to this plus 2x divided by x raised power 3 plus 1. So we are saying let u is actually this plus 2x and the u dx is minus sine and plus 2 this. So at this point we are also saying that v is this and the v dx is 3 that. So let's see how we can introduce quotient rule formula, and dy dx is giving us v. V is this plus this multiply with the u dx. So that is giving us 2 cos 2x minus this minus. So u is this one, so we can include that. This plus into dv dx. dv dx is root of 2. Please divide all this with this. So at this point we can actually see how we can reduce the complexity of the expression. So this time this time this is giving us 2 cos 2x and also minus this and this time this and this time this. And also we have 2 cos and sine x. So having extended this, we have gotten this to this and this. We have gotten this times this is giving us this. Also this times this, there is no 2 here. Please sorry about that. So let's see how we can further extend this. This is 3x squared cos x and also sine 2x divided by, please, this is squared plus 1 squared. So at this point we could see how we can try to simplify the expression, and if at the end of the day we cannot, we just leave it like that. So we have sine x And we also have sin x. We have cos 2x. We also have cos x. So at this point, we can say that dy dx is equals to cos 2x into 2 we have here plus 2. That is taken care of. We also have can write the rest out. Okay, we can also write this plus sine. So this sine and this minus 1, and also, okay, let's this minus here, minus 1, and this is plus 3. So we've actually looked at this, and also we have looked at this. So we've combined this and this and this. So we are left with minus 3 cos this and minus 3, and we can also do this here. Minus 3, we can put this, all of this divided by the denominator and raise the power of this. So thank you very much for listening. This is how you can use quotient rule to actually solve equation of this nature. Thank you.